What up, dudes? Let's get this party started. All right. So, box and whisker graphs. Okay. Let me show you let me give you the gist of what a box and whisker graph is. And they're really easy to make. And I'm not actually going to have you draw them out and all of that kind of stuff. Yes, I'll look over stats 1.4, and you might end up getting like more credit than you guys had initially, and that's probably because I did some of the problems wrong, or I didn't really do it wrong. A lot of times what ends up happening is I make the margin of error too small or too big or whatever, you know. Okay, so box and whisker graphs, what are they? Well, what they are is I taught you guys how to find the median. Okay? The median is the middle number, right? And I talked about the advantage of having the median. The advantage is it isn't swayed as much as the mean is when you add like crazy amounts of things, right? We had that whole Michael Jordan conversation. Are you guys pretty comfortable with that understanding of that? Okay, cool. So the box and whiskers basically indicates 5 numbers. So this number right here is the smallest. And this number right here is the biggest. And this number right here, that's the median. These two numbers over here, I'm going to call this Q1 and Q3. This stands for the quartile 1 and quartile 3. Technically, you can call this median quartile 2. But we just call it the median. Okay? How do you find quartile 1? Well, all you do is you take your data. So say we have a bunch of data over here, number. And then what we do is we split those things in half. So we say there's a bottom half and a top half. We cool? And then we say, well, what's the median of the bottom half and what's the median of the top half? The median of the bottom half we call quartile 1. And the median of the top half we call quartile 3. Nothing crazy, right? Cool. All right. And then what they do is they make a little box around here. And they like to shade this thing in right here. Let me just make this a little bit more pronounced. All right. What the advantage of these medians, or of these box and whisker graphs, is it kind of tells you a lot of information at a glance. It's not good for finding out exact information that you want to know specifically, but it gives you an idea of how numbers kind of look overall. A group of numbers look overall. And we talked a little bit about that. And so let me kind of tell you a little bit about what things that I think. All right. Yeah, it gives you the big picture at a glance. You look at it and you immediately know exactly where things go, where things fall, and all of that kind of stuff. So if you're inside the gray portion of this box, the gray portion is where most of the numbers are. And what that means is like the gray portion represents 75% of all of the numbers. And you think about that, wait a second, doesn't it only represent 50%? No, it represents 75%, remember? Because this is the lower half, this is the upper half, and this is half of the lower half, and this is half of the upper half. And so when you add those together, the gray portion represents where most of your numbers fall. So what you want to do is, like, say that you're taking a test, okay? And say this is how the box and whisker graph looks. If your test ends up somewhere around maybe, let's say here, then you're doing pretty well. I would say you're doing all right. You got a higher score than the middle of the class, so that's a good thing. You're in the upper half of the class. You're not doing stellar. I would say you're doing pretty good. Cool. If you're anywhere inside of this gray box, I would say you don't really have that much to worry. Now, if you get lower on this side of the gray box, maybe study a little harder, but you're not doing terrible, right? Now, what if your score lands like right over here? That's not a good thing. Then what you want to do is you want to ask Mr. Dalday, well, what can I do to make my score better, right? Because what you are is not only are you in the lower half of the class, you're outside of where most of the students land. You know what I mean? Or what if this is a box and whisker graph of an exam and you get over here? What can you tell me? You're at the top of the class. You've got the highest. Yeah, right. You're very happy about that because, or it's either that or you're very sad because you're stressed out because you studied so hard to get to the top of the class. You know what I mean? But it tells you data. You can look at this data and immediately say, I know information about this. So like, what if our box and whisker graph kind of looked like this? If our box and whisker graph looked like this. Okay? Just by looking at the shape of that box and whisker graph, what can you tell me about the students who took this exam? No, it's not necessarily that most people got low scores. No, actually, I would say it's an easier test. You guys actually, it's interesting. You guys actually all came up with the exact opposite of what the answer is supposed to be. I mean, think about this. Say that your median, I don't know, I didn't tell you exactly what the median was. Say that this was 75%. Okay? Then what if I look at this graph, this tells me that, okay, half the students got below a 75%, half the students got above the 75%. Good, I understand that. But the half of the students that got below a 75% didn't get very much below a 75%. You know? Because look, the half of the class fits in this small little section right here. Right? I can't say that more students got above a 75% than below a 75%. That's not true. Exactly half got above a 75% and below, or exactly half got below a 75%. If there's 13 people over here, there's 13 people over here. But what I can say is that the 13 people that are over here didn't get that far below a 75%. Maybe this lowest case is like a 70, which is pretty good. That means my test, that actually tells me that my test was too easy. You know what I mean? If I look at this and I immediately say, oh, okay, everyone passed with a C, even the lowest score got a C, and for the most part, they got very close to that C in that area, and then they also got a range of higher scores. And the range of higher scores is a much bigger range. Does that make sense? So immediately, just by looking at the shape of this thing and how it goes and where these things kind of, how big this box is and compare it to, do they have labels like this in the problems? I think in the problems, they put this right over a number line. So then they go like 5, 10, 15, 20. And then they draw a box and whisker graph like this for you or something like that. And then what you'll do is you'll be able to read, okay, the median is 15, and then they'll have the little tick marks, and then you'll be able to read exactly what the max is and what the first quartile is and the third quartile is and then the lowest point is and all of that kind of stuff. But the advantage of box and whisker graphs is you can look at it and say, this is the gist of what's going on. You know what I mean? And when you're looking at lots of data, that's good to have. I always hated, to be honest with you, before I taught this lesson right now, I never really understood them. I always just thought, okay, this is just something we do. And I've been doing math for like 20 years. But now that I look at it, I see, I could see how this could be greatly advantageous for statisticians and all of that kind of stuff. People who look at data and have to see what the data is saying to them immediately. You know what I mean? But before that, I looked at this stuff and I was like, I don't understand. I don't get it. I mean, it's just something you do. It's not even that hard to do. You just find the median of that half, the median of the lower half, and then you plot out those 5 numbers that is of obviously some kind of importance. Does that make sense? It doesn't tell you the mode, nor does it even tell you the mean. But what it does is it kind of gives you a picture of what this graph is doing, you know what I mean, immediately. And that could be really helpful. Actually, Diamond and Sophia, I agree with Sophia in that it doesn't tell you exactly the median or the mode. You're right. But I actually, when I really sit down and think about Sophia's comments, I kind of think Diamond has a point. And what I mean by that is this. Diamond, you're not right because it doesn't tell you what the mode is. It doesn't tell you the exact number. But if I were to take a stab at the mode, I would say that it's got to be a number between maybe 72 or 73 and 75. I would say it's 74. If I were looking at this and I say, I would, if I had to bet on a number, I would say the mode is 74. And the reason being is because this number splits it in half exactly. So if I had a class of 30 people, then 15 people would be here, and 15 people would be between here. Does that make sense? And so I would say that your mode would probably be like, which numbers would you most likely see that are doubled? I would most likely see that are doubled with the 15 people that are in this smaller gap. So I can't tell you that it's 74. I could tell you that it could be 71, 72, or 73. There's a higher concentration in this smaller gap. So I would definitely say that there's got to be some repeats. In fact, there has to be repeats. There's only 3 numbers in between here, and there's 15 people that have those 3 numbers. So I would say that if you asked me to bet on look at this graph and bet what the mode is. It doesn't tell you exactly what the mode is. No, that's not true. You cannot figure out the mode by just looking at this graph. But I would say that if I were to bet on it, I would say 71, 72, or 73, or 74. That's it. Maybe I would say 73 because that's, I don't know, in the middle of that. But it could just as easily be 74. But I mean, you see what I'm getting at? In fact, if it were 74, I'm thinking that the graph would be more like this. If the mode were 74, then I would think that this space over here would actually get closer to the median because there's, you can fit more people inside here because they're all repeating inside there. Does that make sense? So maybe it does. Maybe this does tell you close to what the mode is. You know what I mean? I would definitely, yeah. Yeah, I'm down with that. I'm down with agreeing with what you're saying. So, but Sophia is right as well. It doesn't tell you the mode, but I could guess where it is at least. But do you see the advantage of this? Is that, like, to me, actually, to be honest with you, I feel like that's all I'm going to lecture with the box and whisker plots. I'm not really going to go any further with that. It just gives me an idea of what's going on and where things are at, and it could be really helpful, especially when you're dealing with a lot of data and you're dealing with really, like, you need to look at a lot of data. So, like, Bradley, you want to be an anesthesiologist, and I always bring this up to Bradley because, I mean, you want to be an anesthesiologist. You're going to have to look at a lot of data from, like, reports that come back to you and says this is the reactions that somebody has. Yeah, we're always picking on Bradley because it's a running gag at this point. No, I love hanging out with you. I love talking with you guys, especially you, Bradley. Well, all of you. But anyway, you're going to have to look at a lot of data. I'd imagine that something like this might be helpful. You know what I mean? And then what you can do is you can say, well, this is where, you know, like, what you're going to do is you can't say, I know exactly how people will react to this medicine or this dosage of medicine, but here's the box and whisker plot, and I better give somebody the dosage inside of that gray box, you know, as long as it's within the gray box, because that's where most of the people fall. You know what I mean? And you don't, like say that you're doing a dosage calculation and you got to figure out exactly how much. In regards to accuracy and specific, I agree with Thea, but you don't. But if you were doing a box and whisker plot for increment amount of smoosh, yeah. Like I said, and I thought I said that. It was like, this doesn't give you the exact points. I mean, it does tell you where the numbers are, but it doesn't tell you. All it's telling you is the trend of what's going on, the gist of what's going on. You can look at a box and whisker graph and say, I see what's kind of happening here. You know what I mean? If you want to look at exactly what's going on, I would plot out the data and actually, you know, look at the numbers directly. But if you're looking at, like, you want to look at a picture and get all of the pieces of information on it in 3 seconds, box and whisker. That's the only way to go. Unless you want to look at all the numbers and say, this is the trend of what's going on, the gist of it. I mean, you got to be a freaking computer for that. In fact, they have computers for that. And you know what the computers do to produce things that the people can look at and immediately tell? Box and whisker graphs. Right? That's how we are able to interpret the data that the computer immediately spits out and looks at it, sees the trends, and then it says, well, here's a human can't, you know, calculate all of these things, so it gives us a box and whisker graph. Yeah. It tells me the gist of where things are at and where the outliers are and where this one is. And, you know, like, if this number is really big over here, like, what does that tell you? If there's a big gap over here, what does that tell you? Yeah, that it's probably only a few people that are out here, and it's probably only like 1 or 2 people, and this person probably just straight up aced the test. You know what I mean? And this seemed like it was a kind of a hard test because they're far away from the outlier. So immediately, just by drawing a different picture, you guys are able to tell me, make up new stories about it, a new scenario, and read that and say, this is generally what I think is happening. And that's powerful. That's amazing, actually. If you really think about how awesome you guys are, that's pretty cool, isn't it? Anyway. Yeah, I think, Bradley, what I would say is maybe for you, you know, you want to figure out how much dosage you need to give somebody, but you don't know exactly how much you should do. You know that this person has is very resilient to drinking or something like that. So you know that they're probably going to end up being on the higher side of the amount of medicine that you give, but you don't want to give them outside of the gray box. Because if you give them that, that's like, you know, that's not the majority of people. So then you decide, I think I'm going to give them this much concentration of, I don't know, Vicodin or whatever medicine that they have. You know what I mean? Because you can't test it. You just have to go with the average, right? And you don't want to choose. What you want to do is you want to get a better number than just the average. Does that make sense? So what this is it's kind of like an average, but it's a range of things. And this box and whisker graph isn't as swayed by the crazy outliers. Like this is the Michael Jordan of things, right? The median didn't move very much. All right. What are you guys talking about? Okay. I think that physics class starts at 1:30. So I go from 12:45 to 1:30. Okay. Oh, they have box and whisker plots for your grades. Is that what you guys are saying? Okay. I'm not really gonna. I'm gonna move on to section 2.2. I'm not really gonna talk about the mean. The mean is. Do you guys need me to show you how to calculate the mean of something? Right. That's the same thing that you guys did back in fourth grade or whatever. Actually, my sixth grader is learning mean and that kind of stuff. I will show you this though, because this might freak you out. All right. Mathematically, higher level math courses rate the mean like this. Write that down on a notebook. And I'm going to break down for you what this means. Okay? It looks crazy. It's not. It's not at all. All right? Mathematically, this is how we write the formula for the mean. All right? This is stats 2.2. All right, let me just make up a few numbers. Let's go with like this. 3, 4, 7, 9, 2, 11. Okay? If I wanted to find the mean of this, what do I do? Oh, this is an 11. So 2, 3, 4, 7, 9, 11. And I just made some numbers up. Yeah, you add them all up, so it's 2 plus 3 plus 4 plus 7 plus 9 plus 11, and then divide it by 6, right? So you know how to find the mean, but what the heck is this notation? Okay, first of all, are you asking about this thing right here? It's an I. A little lowercase I. All right. Let me break down this equation for you, because if you see this in your advanced math class, like calculus or something like that, I don't want you to freak out. It really is as easy as adding up all the numbers and dividing by the number of numbers you added. Okay, let me break it down for you. What we do is we say, okay, let's say that this symbol right here, that just means find the mean. That's the symbol we give when we put a bar over the number or over the variable. We're saying that's the average. Okay? So that bar over the thing just means find the average. Do you guys know what this symbol right here is? It's called a sigma. It's a Greek letter. We use this in physics a lot. And all it means, literally, is add up the stuff. If it's all right with you, I'm feeling nostalgic. I'm going to put, there we go. Add up the stuff. All right. So it just means add up everything. The reason, I see what you're saying. Why don't you just put a plus sign? Okay, all right, fine. Here's why not, okay? Because what it does is it helps you add up a large, this is like writing, add up everything you see. Well, let me backtrack a little bit, okay? See this list of numbers that we have? I'm going to label those numbers. I'm going to call this x1, x2, x3, x4, x5, x6. Does that make sense? This is the first x, second, third, fourth, fifth, sixth number. We cool? So, if I were to write this, if I were to write sigma I equals 1 to n equals 6 of xi, then what this is saying is x1. So you start with plugging in I equals 1. So you put I equals 1. And then you want to go all the way up to I equals 6. So you go x1 plus x2 plus x3 plus x4 plus x5 plus x6. I'll be honest with you, Bradley, I would rather write this than write that with the plus signs. Right? And then x1 is 2, 3, 4, 5, or 7, 9, and 11. So 2, 3, 4, 7, 9, 11. So that's what this symbol means. So usually you'll see, on the sigma, you'll see a number on the bottom, and usually it's going to be like I equals 1. And then so what you do is you plug in a 1 over here, and then you do it for 2, and then 3, and then 4, and 5, and 6, and you keep on going until you reach the number on top. And in this particular case, the number on top is 6. Why? Because there are 6 numbers. That's where you stop. There's no point in going to a 7th because there's no 7 numbers. Does that make sense? N is the number you stop at. It's also the number of numbers. Remember, you guys have that weird saying of like, you add them all up and then you divide by the number of entries that you added, right? That's N is. N is the number of entries that you have. And obviously it's the same as where you stop, because you go the first, second, third, fourth, fifth, and then 6 number. It's telling you that 6, N equals 6, that's telling you to stop at 6. So if I were to follow this formula exactly, this is telling me to find the average x, you add up all of the numbers. So you add up all of the numbers, starting from 1, ending at n. They didn't write those pieces of information in there. Usually they put a sigma I equals 1 to 6, and then they go like this. I forgot to write that part over there. But this is saying starting at 1, and then going, adding the next one, the third one, the fourth one, the fifth one, but stop at 6 because that's what you want to do. And then divide by 6. This is the shorthand way of writing that entire sentence. When I asked you, how do you find the mean? You told me, okay, you take all the numbers and you add them all up, and then you divide by the number of entries that you had. instead of writing that sentence down or even typing that sentence down, I would rather write this. Because mathematicians are incredibly lazy, and this is our lazy way of writing that down. So when you see this, don't freak out. It's just math in math language. And it makes perfect sense to me. But that's the power of it. And I'll be honest with you, I use this a lot. I is what we call a counter. It's just kind of, we call that a dummy counter. And what that is it's just a like a variable where you start at 1, or sometimes they say I equals 0. You can start at 0, and then 1, 2, 3, and it just counts all the way up till the number that you need to stop at. So I is a number that changes, starting at 1 and doing this. In physics, what we always say is F equals ma. Have you ever seen that equation before? Some of you have taken physical science, and this is the equation that they showed you. Technically, the equation is this. And you know what's sad is I've seen people actually, I saw on a Facebook post a couple years ago, a student got this tattooed on their lip, on their face, F equals ma, And it was because the teacher said, if you tattoo this on your face, you're going to get an A. Because this student, she was getting an F, right? So she tattooed F equals ma on her face, right? And then the teacher got in big trouble, and I'm sure he got sued and fired and whatever. And I would never even suggest that to a student. What an idiot of a teacher. But what's even worse about it? Yeah, I know. I'm not suggesting that in any way. Yeah, idiot student, idiot teacher. They're both idiots. They can go and be idiots together. But the worst part about it is she didn't do it right. Like, if you're going to get a tattooed on your face, make sure it's the right equation. Because then you just look extra stupid, right? Because technically what she should have done is tattoo this on her face. Because what we do with it in physics is we said, we want to add up all of the forces, and that's going to equal to the mass times the acceleration. But we have to add up all of the forces, because there's multiple forces pushing on this one object. And we want to add them all up, and then have it equal to mass times acceleration. Sadly, that student only had that tattooed on their face, and that only accounts for one of the forces of the many that there could be. So in physics, we never write F equals ma, we write this. So, stupid teacher, stupid student, don't ever do that. But I'm just saying, that's how we would use it in the real world. Right? This is signifying to us that what we're going to do is we're going to add up all of the forces and then set that equal to the right-hand side. But on the left-hand side, that doesn't signify just F. That signifies F1 plus F2 plus F3 plus F4 plus ... F sub n. This is add up all of the forces until you get to n. So technically, maybe I can even put this, F sub I. Because the I starts at 1, and then the I goes to 2, 3, 4, all the way till you get to n. So you have to add up all the forces on this side is equal to mass times acceleration. Now, in physical science, when you first saw this equation, I'm sure that the teacher didn't show you sigma F equals ma. Because once students see a Greek letter that they've never seen before, they freak out and die, and they say, my brain is too small to handle this. I'm going to quit now because I'm just going to be upset at Mr. Dalday because he's trying to teach me crazy stuff. right? That so what we do is we limit it to just F equals ma because we're like, oh, that's a cute small little equation where you can just say the force is equal to mass times acceleration, and we can only account for one force. But no. In the real world, there's multiple forces. There's the weight that's pulling down. There's the friction that's going sideways. There's the normal force going up. There's the pushing force going to the side. There's lots of forces that could be acting on one object. So what we need to do is we need to account for all of those and not just say F equals ma, but F1 plus F2 plus F3 plus F4 plus F5 plus F whatever, however many forces you have acting on there equals ma. So there, a direct application to this crazy symbol, and immediately you guys are like, and so what my job to do in math is to teach you why the hell should you care, and also how to read this stuff. Because this isn't really that hard. This you already know how to do. It's just written in a way that freaks you out. But after you get it, after you have experience with it, after you internalize it, you look at that and say, oh, I get what's going on. Yeah, I can see that. And the advantage of this is we can use this same notation to do much more advanced things. All right. Anyway, I gotta go. I'm late for math or physics. So, talk to you later. I'll take a look. I uploaded this week's archives already. They should be up. All right. I'll take a look at 1.4. And most likely, I'll give you the points. I'm just letting you know. All right? No. I hate giving points if you didn't take something. So at least try it. At least try it and fail it. If you try it and fail it because I did something wrong, at least I know that you're not getting freebie points for doing nothing. That bugs me. Okay? All right, anyway, I'll talk to you guys later.